G'day, g'day. Got a few things to look at today. Going to revisit the Gold Monster um, and see what we can do to the Gold Monster. So there are some extra things we can do to this detector. And first of all, rather than going into the technicalities of it, I found some interesting information on the web about the Gold Monster. So we should check it out, actually. I thought it was very interesting. I think a lot of owners of gold monsters will think it's very interesting as well. So first of all, there's a few things I wanted to go over. First of all, we'll go over the coil and the electronics in the coil of the gold monster, and we'll go over the circuit board of the gold monster. And yeah, there's a few other little things too. That I was going to pick this up, move it round. So this may end up being a long video. Skip ahead. If there's any bits. That's Dave got me that. That's really good whiskey, that one. So I'll give them a free plug. Yeah, I got another bloody lurgy. You know, a while ago I got the COVID and I thought, oh, that was nothing. Then I got this other thing. It's just recently only had it for about 3 days, but you cannot stop coughing, and because you can't stop coughing, you can't sleep. And you can't sleep and you start running down and feel absolutely horrible. And you get, anyway, it starts with a tickle of a sore throat. And I don't know if it's the flu or this thing they call some RSV or something. Anyway, I don't worry about it. I just vitamin up and overcome these things. Anyway, I found this on the web. Have a look at this. Catapult. That's the website. It's an Australian website. I'll see if I can get this right in front of the computer, which means I won't be able to operate it probably, but whoops. There we go, we went airborne. Okay. If we're not square on, it's going to look horrible. So, how's that? Something like that anyway. It's not perfectly straight, but oh well. There you go. Found this site. Anyway, let's go over it. It says Catapult. And I had a look at, well, this is giving them a free plug too, isn't it? But I went over the website, and this company, Catapult, is an industrial design company. And it looks like Minelab have employed them to do their industrial design on the Gold Monster detector. And I went and had a good read of this, and it actually reads very well. So if you want to find out more about your Gold Monster, catapultdesign.com.au. It's well worth having a look at. And as you can see, there's a bit of information here. They do industrial design, engineering, prototyping, visualization, user experience, user interface design. And it's quite interesting that the Gold Monster is designed, more so I'd say for the African market. If you read up, I've read up the Coden yearly reports and quarterly reports too about their market and the rest of it. A lot of money in metal detectors. I think they made 74 odd $1 million out of detectors last financial year. And Africa's slowed down for them as well, they say. But anyway, I'm not going to get into the nitty gritties of Coden's operations. But yeah, there's your Gold Monster, and a lot of drawings and the challenge. And that's what it basically says there. The challenge was gold detection in a major market in parts of the developing world, including Africa and Asia. And what they did with the Gold Monster, I don't know how this come about, and I don't know the reasoning for it, but it's actually designed that if, okay, it'll sound weird to probably many people in, Europe, US, Ausland, anywhere, where, metal detecting's been going on for many years. But there's a thing in here about if you break the shaft. I don't know how you break the shaft, but it might. I don't know. Is it a common thing in Africa? They bolt them into the ground or something. I don't know. And it says, oh, if you break the shaft, you can replace it with a broom handle. I thought that was rather interesting. So it's the ergonomics of it is meant to be very lightweight. We all know it's very lightweight, very easy to use, very easy to swing. And if you break the handle, you can stick a broom handle on it. But anyway, so you have a look at the website here. There's a lot of information. That's just the main part. So before we get on to the Gold Monster, on the technical parts of it, I bought this on the web. I was just going to show you this. If you've got a workshop, this is so damn good. This thing, okay? It's a vacuum cleaner, and I thought, oh god, this is going to be a toy. And you charge it via USB. I'm charging it off the computer on the USB plug at the moment. It has a lot of attachments, and I had a good look at this thing, and it's got a little filter in here, a little conical type filter. And the thing I like about it, because it's plastic. I'm trying to work around the tripod, and it's a bit awkward. But if you're using it on, sweeping up or cleaning up your electronic bench, you can see if you inadvertently suck up any electronic components. And yeah, it's very powerful for what it is. It just pops apart like so. You empty it out. You can get new filters for it. And this thing with all the attachments was $20 or $22. I've got it here. Yeah, there's heaps of them on eBay. There you go, that thing. Um, yeah, handheld cordless vacuum cleaner. Uh, and the thing too, it also has an air blower on it. It comes with an attachment that goes on the back of it, and it oofs out enough air that you can actually blow leaves around outside. And I thought, it was going to be a toy, but yeah, have a look on the web. It's cheap, $22.99 it was. I think. I think I got this one here. Um, well, they're all the same, more or less. Um, but if you turn this thing on, like, just listen to this. It's like a hairdryer. So it charges up fairly quickly. Uh, but yeah, it's something really good to have for the workshop if you've got a workshop, and keeps your bench clean. When you're chopping wires all the time, and you're stripping wires, and it just builds up and gets a bit out of hand. Anyway, we'll go back around with this. My room's a bit squashed at the moment. I've been working away on various things, and the detectors have been building up. Getting a lot of detectors from overseas again. A lot of older detectors that people want to go very, very deep on big, large targets. A lot of European treasure hunters looking for cache treasure, and also big silver hunters in the US. I think a lot of them are from Alaska and Nevada, of all places. Silver, big lumps of silver, and they want it to go very, very deep. Anyway, back to the monster. Now, when the monster came out, I thought it was a bit of a toy. I said, oh, it's not that expensive, a bit toyish. But the more I look at it and examine it, I mean, it's actually very damn good on small gold. I remember the detectors we used to have, like, you know, very, very tiny gold, like some of the Fisher detectors, very, very good on tiny gold. Um, there's all sorts of white detectors that used to exist that were very good. All the VLF detectors, basically, same as this, a VLF detector. But this thing here, very easy to use, and yeah, it can be upgraded. There's more upgrades. The more I look at it, the more I can find. It's not saying there's a design deficiency. It's it's like if you've got a car and you put a spoiler on the back, you can go around corners faster, and because you've got more downforce. Little add-ons. You've got an existing product, you modify it to do better or be more efficient or do something a little bit different. Anyway, the thing we'll get onto on this one is the coil, right? Now, it's a real job and a half to pull the coil apart. You notice here that I had to drill holes through it. I didn't have to do the middle hole. I only had to do the outside ones. And the reason being, if you look at the design here, I'll just do that. These posts, there's 4 posts that went all the way through the coil housing structure, like the bit that holds all the electronics together, and it's heat plastic welded or ultrasonic welded or some plastic welding technique that welds the bottom to this. And also, I don't know how this is stuck together, if it was glued or it's heat welded again. It's a real pain to pull it apart. It's made to be waterproof, and thus it's more or less hermetically sealed. And even if you have a look at the cable, I'll pull this out. I don't know if you can see in there. I'll see if you can see in there. Oh, anyway, down in there, you got a little circuit board, and that's got the preamplifier and analog digital converter on that board. And I don't know if you can see the potting mix in there. It's got yellow potting mix with the wires into this area here, and it's sealed. It's made so you really can't get it apart. You'd cause a lot. You'd break the wires getting this out, so it stays like that. Uh, but there is things we can experiment with on the course. I'll show you a few little interesting things. I'll just use an. Oh, have I got that in frame? Have I? No, I haven't. Okay, I'll just have to use it. The cheap meter. I've got the flute meter over there hooked up, but I'll just use this cheapie so I can get it in close. Okay. So I've got this on 2000 ohms. And if you look at these plastic structures here, there's one here and there's one on the other side. One's transmit, one's receive. Actually, as of yet, I haven't worked out which one's which. I'm going to do that. But if you actually go on the plastic, you think it's plastic, there you go. It's all over the place. It's because it's very slippery. You can't get a fixed reading on it. So, you know, what are we getting? We're getting down 100 ohms, 200 ohms. It's bouncing all over the place. 400 ohms. But if you look down on this part here, there's a little wire there which is clamped into the plastic. And you can get on that wire, which is better connection. And then try and hold it up here. What do we got? It goes very low when you do that. So about 50 ohms, 40, 50 ohms. So it's very hard to get a proper read. What you'd want to do is you'd probably just want to clean this up a little bit, and try and maybe do what they've done here: embed a small thin wire into it, and just put it on a hard connection there and hard connection there, and just see what it is. So my guess is it's getting down to probably around 50 ohms or something of that nature. It's not very, very high. And my old thought on conductive shielding around a wire, you got to think back to transformer theory, and that would act as a partial shorted turn. So But is it of a structure that's even though it's acting as a partial shorted turn, does it not have any impact on the high frequency waves and the return signal on the way it works? Yet to be proven. So with this, you can have it pop it out. It's just gripping on the remains of those posts after I drilled the ends off. So you can see that it had hollows here. This is a hollow part, and this bit here was actually where it drilled off. So it had posts, and it went into little round hollows, and they're all full of glue. You'd never break it out. This glue, this yellow glue they use, it's tough as. So rather than the glue breaking, the plastic breaks. So if you want to play in these coils, you'd have to chop these right back, and then you'd have to fill these up, uh, clean up where you have a look at the effort I've gone to trying to get this apart, get off the skid plate, and you can see around the edge there that I've really had to chew into it. Um, you know, and if you look at the overall design, a better way to pull this apart if you wanted to is on the edge rather than just butchering the plastic here like I've done. Without doing that, I couldn't get it apart. You could probably just, you know, put the coil up on some sort of something like a bandsaw or something like that, and just slowly work it around. And if you look at the design of the coil, you could actually, you know, go in, 3 or 4 millimeters or so. You're not going to hit anything, and then you could separate the coil um, on the outside that way. But the problem is still these ones here. You're going to have to probably a good way to do it, rather than the way I did it, is you can get a small core drill, and if you can work out where these spots are, you could just make it a little bit larger than the post, and you could drill it out. Yeah, this one's got painted black, but you can drill it out, just a mil or two more than what the diameter of the posts are, so it comes away cleanly. But you still got to fix your holes, otherwise water's going to get in, and that's the end of your coil. So we've discovered these things are shielded right around. I don't know if it's optimum. I can only give my opinion, right? And that's all I've got to give on this. That I wouldn't shield it that hard, that low in resistance as a circular complete covering, like a turn. It acts the same as a turn in a wire. It's a transformer action. You got lots and lots of turns, and you put this big fat conductive thing on there. It's acting as a turn, but it's more or less a 50 ohm turn. But then again, it's also made out of graphite or carbon or some other material, and it may not impact too much at high frequencies. This is something I have not played with. I have not done any testing. I don't know. So speculation, opinion. We could, if you look at the way these are connected here, we could pop these coils out. Probably needs a little bit of, it's got glue in there, of course. But if you're very careful, and this plastic's as brittle as, like a dry biscuit, it's really brittle. You could pop these out. Um, you know, don't break the wires because the way it's all put together, and experiment. You could, I don't even know if you could separate. I don't know how it's made. I don't know if you can separate it. Oh, tickle of the throat, like I say, too many lurkies going around. And Maybe you can separate these. Don't know. I don't want to wreck this coil because even though it's like it is, it still functions. So you be careful. Uh, it'd be microsurgery doing it, but it could be done. I'm pretty sure you could do it. Worst comes to worst, what you could do is you could probably just you know cut these out, and you could just look at the gauge of wire, get some more insulated copper wire, and just do another rewind your own, and you could change the shape, and you could also change your shielding. You could go to some sort of you know painted on carbon shielding. Like I say, totally experimental. If you really wanted to experiment with this, you'd probably just completely destroy the plastic, get the circuit board hanging on the end of the wires here. Um, you know, just take some measurements of what sits where, the distances, and so forth as a reference. Then just break all the plastic away and have it all free float, and set it up so you can work on it, or remove and add. You could try putting some light shielding between. This is another idea which I haven't done, but this is a good idea if you ask me. If you put some sort of um, carbon sheet in this area here under the board, so you don't get a ground to board interaction if there is any. There was patents that a company applied for some while ago. I think they all got knocked back. I'm not 100% sure. Where some of the solder joints on the wires and metallics in a coil were covered with a blob of ferrite material to stop um, secondary ground interactions with as a return signal from the ground into the wire, causing eddy currents to hang around and then come back into the receive cycle. I think that's how it worked. Like I say, I didn't come up with the idea. I came up with a different idea, but I'm not going to mention that. But you could do something like that, and then just do some testing on hot ground, or what I've got here. There it is. This is ironstone pure. It's granules. That is really nasty ironstone. That came up from I think somewhere near Great Western, near Stawell in Victoria, and that is dynamite stuff. That is very, very hard to ground balance out. So you could get something like that as your test medium and experiment. The other thing as well, if you're looking at this, maybe you could actually layer it up with. It's very well. I think you could actually paint on that. You could paint that with graphite carbon shielding paint and do test. And you could probably set up what I usually do here. I set up my sweep generator covering a lot of frequencies, and I've got a wideband power amplifier which I hook into it, and I'll just run some cable, just a couple of turns over there on the other side of the bench, and cause interference on purpose, sweep a large spectrum from a couple of hertz all the way up to a couple of kilohertz odd. And if there's ways and means of doing it, then you could set up a setup where you can actually start doing into the HF radio spectrum all the way up into where mobile telephones operate, to sweep um, frequencies through and just see what interactions you have. You can then narrow it down, narrow your sweep rates down until you find the frequencies that are interfering. Then you can look at techniques to minimize interference at those frequencies. But that's a lot of mucking around doing that. But if these things are susceptible to particular frequencies or ranges of frequencies, if you identify it, you can take action. So maybe with extra shielding on this, you may have a benefit. In some situations, VLFs aren't really affected too much by interference, but in some situations, maybe if you could orientate the coils differently, put them on the same plane instead of one stepped up above the other, you could, work out what is the best orientation. It's probably been worked out already, but, I don't know that. So that's why we experiment. We try things. You could, actually, with this, you could get a larger coil shell, crack all the plastic off, and just rebuild the whole thing into a different coil shell. And the coil on the back here, you can see the way it's designed. It's got a little step in it. But you could actually, bring this one down here. The closer the coil to the ground is going to give a more, for the receive coil, it's going to have more receive recovery on small targets, because you got a distance thing here. This coil's up away from the ground. It may be causing less ground interaction, but if that's a receive coil, which I don't know which one's which, that will diminish the return signal. It just won't be as strong going that little bit of extra distance on a very, very tiny gold. So there could be an advantage in changing the configuration. You could snap these out, get rid of this whole plastic housing, and just build up your own coil and just build it all on a bottom part. There's in the US, there's a company who sells coil shells, all different sorts and sizes. I think they're still in existence. You could get one and you could just retrofit it and make your own coil with the internals. You need to keep the board, of course, because that it probably will have some coded data transmission into the receiver board. So if you don't have that dongle code, the coil will not work on the detector. So I'd say it's rigged up that way. I think from memory, I looked at the board. Someone pulled one of these out of a detector. I think they destroyed the coil doing it, but I think there was a little, I think they call it a little I2R chip. It's a three-legged thing, and it just generates a code in response to another code. So it's a handshake chip, which is not really my bag of things doing that, but they exist. So yeah, you'd have to keep the board. You could change the coils, of course. What's stopping you utilizing this? Well, I know they make bigger coils than this, but you can make your own coil assemblies for this. There's nothing stopping you doing that, and just wire it back into the board on the same points where these are wired. You can make it, if you really want, you can make a huge coil. There's nothing stopping anyone making an 18-inch coil. Not that it's, that good an idea doing it on a VLF. I mean, it's not going to go very deep through mineralized ground, not like a pulse induction detector, but you can play around. But these work really, really well for what they are. But what I think I might do, how about we work out which coil's which one is the receive and which one is the transmit? Because I have never done it. So what we'll do, we'll get the board and we'll put him back in. Now, you got to remember this. When you pull it apart, this thing pops out. It's a rubber cover. And what we do, there's a switch on the board, which is a battery pack impacts, it goes right there. So keep that in mind, don't lose it. Else when you put the battery in, it's not going to push the switch and the detector won't turn on. Anyway, round we go, we put it back together like so. Don't wreck the little mylar strip there. Can you see the mylar strip? Don't wreck that. Don't get it caught under, make sure it pops up. And usually I get something like, use a multimeter probe. Get in there and just pop it up like that, just so it doesn't get caught. So, not really an optimum way to do this, but what I'll do, I'll just put a couple of screws in the right spot, just so it doesn't fall apart. I'll hold it apart, hold it together, hold it apart, gee. Okay. I'll put 2 screws in it so we don't get any massive torsion or deflection on the board if we start poking it or something. Nice and gentle, never over torque. So what we'll do, we'll get the battery pack, and you see the little divot here, little poke out, whatever it is, that thing there, that pushes on that switch I was talking about. So in goes the battery. I'll put the battery cover on, clip it into lock position. Then we'll get the coil wire. I won't put the front panel on. I think I've worked out what switch is which by now. But yeah, you can tell this is just basically a data cable. It's got a lot of wires in it. It's very, very springy. Whoops. So put it on like so. Get the detector away from metal. There's probably metal in this wooden bench because it's got screws, nails, and all sorts of things in it. So we want to turn this on. The memory, that's the power button. There it goes. And first thing I did, what did I do? I forgot to connect the mylar strip, and that connects the speaker. I'll turn it off. Okay. When you put the mylar in, so I'm getting ahead of myself. When you put the mylar in, like so, make sure the plastic here is out. Don't push hard, a little bit. Wiggle the mylar a little bit like so. Push there, there, and back and forth. And it's in. It will look like it's out a little bit, but that's how it sits. No big deal. Now it's going to make noise. Okay. Well, it's hearing itself. So what I'll do, we want to find out. Okay. Sensitivity is a little bit. Okay, we'll keep the sensitivity down. It's just me moving the coil around. It's gonna make noise. So, as a matter of interest, let's have a look at. We'll have a look at. I'll try and hold the coil away from it because it's going to interact. But it's going to interact with the camera as well. Let's see what happens if I touch it. Okay, my hand is reacting with the coil. My hand. Of course it is. You know why? It's got a ring on. That's why I never wear rings usually when I do this, because it's setting off things. And it's also dangerous working on electronics wearing rings. But okay, let's see now. I said that's really reactive. Oh, don't wear rings. Well, it can pick up my hand. It is having an effect, but I'm not actually touching it to do that. So touching it, it's not touch sensitive. Maybe if I turn the sensitivity up, it would be. But what we're going to do, we're going to work out which coil. And what I'll do, I'll get my tiny, tiny little bit of gold over here on a stick so it's isolated, which is at 0.05. Okay, we'll see how sensitive it is to. I'll get it out of the housing a little bit. Out you get. It's going to go nuts because the cable's jumping all over the place. So you know, on a double D type coil or a loop coil, the sensitive bit is where you get the most phase change in the middle between the coils, or where the wires run beside each other here through that plane there. So what we'll do, we'll try it again here. Actually, 0.05 is probably a little bit big of a target for this, but we'll do it. And on this side, I should be able to work it out by the response, which one's which. Okay, but the thing is, it's so tight in here, it's hard to do the same thing. Okay, I'd say the one closest to the ground, or the bottom of the coil, is a transmit coil, and the top one's a receive coil. So that is possibly set up that way to get less ground interaction and make it an easier to use detector. But I'm pretty confident that's how it's configured. I mean, I could probably, if I could actually look in here, if the wires weren't stuck like that, I could actually track it out from the board to the receive preamplifier to what winding goes to what coil. But you know, I'd have to bust all those wires there, and I don't want to do that. It's just too hard. These, I really think, are not meant to be pulled apart once they're made. It is meant to be sealed as such. But yeah, there's a lot less interaction with the coil towards the bottom, which usually indicates it will be the TX coil. And if you do it in the middle of the two coils, it's going to have the same effect each way. It's not going to. It's just the way. It's very, very sensitive in the middle there. But you could probably drop the sensitivity way down on this to the lowest setting, and get right in and just about touch things, you know. So right, and then do it here, and it's a lot more insensitive. So that to me is the transmit coil. That one and that one in there is receive. It's still a lot less. I may be wrong, but I think I'm right. So with this, you could try anything. Say you do suffer interference, say you're getting atmospheric interference. How about on this side of it, you can put a shielding, some shielding material, a big circular piece over the whole thing. Make sure you ground it to the outside of the coil, either with conductive wire by just embedding it. Touch it with a soldering iron, a little bit of wire, just melt it into the plastic. And a good spot to do it would be where it's already done on this side here. There's a little bit of extra plastic there you can actually use. So tack your wire in that way, or using a conductive epoxy, and put a carbon-based type material shield there. You can make your own up. Just get some of that shielding paint. Oops, and which I put away, whatever it was called. But anyway, you can make up your own mixes and change the resistivity of your paint, and you can try different things. But you need to separate the coil to do that. Yeah, so that's the Gold Monster. I've already done some stuff on this one here on the board, and it actually improves the stability of the detector. So a little bit of secret sauce. So you're going to crank these things right up. Right, that's on auto. It's not going to do much at all on there noise-wise. It's very quiet, but we'll crank it back down to manual flat out. And very, very sensitive. It's not bad at all. I haven't actually thrown this tub of Vinestone at it yet. We'll see what happens. Well, it doesn't like it because it says it's iron, but no, I got the sensitive flat out. Yeah, it wants the ground balance. So look at make it a little bit less sensitive. You can overload it and probably confuse it, but that's, like I say, that's pure. You can't really see in there, but that's pure ironstone. This is heavy. It's like picking up a big iron weight. But yeah, that's all right. Biggest test with these detectors is when you have something like ironstone in front of it, like there's a big tub. You get your small bit of gold, and you know, and it totally ignores the ironstone, still picks up the gold. So no confusion there. I really think that's impressive. Uh, Very, very good indeed. Go for deep. Damn impressive machine for how it works. It really is. A lot of um, inputs gone in on these detectors, and you know, pretty hard to impress me, but I am impressed. I do like it, even though it's one of the cheaper detectors. It's not going to go super deep. Um, you know, you're not going to go find a hand of faith, 800 and something ounce nugget down at 4 feet or something with it. It's not going to do that. But surface gold specimens, you're not going to miss much with this, especially with a small coil like that. And overall, 0.05 gram target, not a problem. So doing mullic heaps and stuff like that, fantastic, fantastic, not bad at all. And I didn't even attempt to do anything like ground balance it or optimize anything. It just works. But no matter how good something is, you can always modify it. You can even get you know anything like that's why they modify race cars, go faster and um, stick on the track better. So everything can be modified, and there's always a benefit. But I'm quite impressed. Another thing I should point out on this, we'll turn the power off just in case. Um, I hope we've got enough light there because I've got the top light on, but a bit too much background light, but anyway, I might as well point this out too. You can see here there's a picture, or what we would say on the screen print. There's a screen printed picture of a switch. So, and there's provision there for a tactile switch like these, same footprint. So this is, you could have a switch, and look here, there is one, two, three, four switch positions on another one here. There's a connector here, J502. Obviously, it's not used, nothing sold in the holes. But there's things that can go on this. You know, you could actually, I haven't tried it. I'm not doing it with someone else's detector, right? Because I don't know where it goes into the detector, into the microprocessor, and what actually happens. But, you know, does this switch bring on a different function? Does anyone know? Has anyone tried it? Because when you look at that, there's another switch position here. There's another one down here. And there's probably another one there I haven't noticed. Is there? I don't know. Maybe, maybe not. But, you know, when you see stuff like that, you go, oh, well, it is on the overlay for a switch. What would it do if you actually added a switch here? You know, does it light up another function? Maybe the other function for this switch is for another model, possibly. I don't know. Where the next model has extra code put into it, and these switches activate that code, or was it functions that were initially designed in, and they said, well, guess what? We don't really need that. It's more fluff than what it's worth, and it was omitted. That I don't know. Be good if someone did know and could leave a message. And you know, there's people out there who know, of course. I don't know if they'd actually say anything, but yeah, it'd be interesting to know what the extra switch positions are. You know, you can measure it out, but a lot of it's just code running around, and you know, it's you don't know what it means, what it does. It's just too damn difficult for someone like me to try and work out. But yeah, that is the Gold Monster revisited. So I'm impressed. Um, I'm actually thinking of getting one of these for the missus, because you know, women don't like digging big. Most women, I should say. Well, I'm probably thinking like a guy, but I would think most women don't like digging great big holes. Some do, I suppose, but this would be very good for surface gold, mullock heaps. Um, you know, anywhere, just hill wash, where you got little bits of gold come off a reef down a hill. It's all light and floaty, stays on the surface. You're not going to miss it. So yeah, um, that's probably enough of a waffle on this Gold Monster. So this one's come in for its upgrades. That's not its coil. I just keep this coil here as a test coil. And if anyone wants their Gold Monsters, made a little bit more stable, well, actually, it works out to be a lot more stable. Actually, on the website, it's on one of these. I did I think it's one of my videos. I did the detector. I did all the extra work to it, and the fellow's gone out up to Palmer, and I think he got 187 bits of gold. There's some write-ups there on the website. You can have a look at it. It's in the comments. Um, yeah. So go and have a look at that if you want. Um, I don't know if you I don't know if you can put pictures up. You can't, can you? Yeah. So if you've got pictures of your 187 bits of gold, you should send it in. I'll put it up on the website, or then I could put it in the next video too. Just do a video of the screen. there you go. Good, nice, cheap detector. Like I say, it's not going to be, you know, the big grunty deep gold finder, but it's going to find gold. It's going to find all the small crumbs. It'll find big stuff too, of course. If if the gold's just a couple of inches under the ground, you're going to find it, no matter what it is. Uh, That's the gold monster. Anyway, um, so that is that. All good. Catch us later.